Andrew, could you tell me a little bit about yourself, your background and your expertise?
Hello, my name's Andrew Beggs. I work at the University of Birmingham as a professor of cancer genetics and surgery. And I have two jobs. I'm a surgeon and a scientist. My interest is in how we can analyse the genetic code of cancers to improve treatment. And I've been concentrating that mainly around whole genome sequencing.
And more recently, you've had to redirect your efforts, I don't want to say away from cancer, I'm sure you've probably got to do two jobs, right? Tell me a little bit about how that's come about and how you're managing to do both.
So right at the beginning of the pandemic, we realised there was just no capacity for analysis of COVID for people having COVID testing and COVID analysis. So we repurposed the equipment we have in the lab that can be used for a lot of same things for COVID to do COVID testing, diagnostics and sequencing. And we turned that around. We went from being a cancer genetics lab to a COVID testing lab in 3 weeks. And it brought together a whole team of people I'd never worked with before, virologists, pathologists, people in the category 3 facility, which is what we use to keep the virus safe from the public, and also the people in microbiology who would be sending us the samples. So it was a real team effort.
So can you tell me a little bit about the rapid sequencing tests that you're working on, looking at viral RNA? What was the problem and what solution have you come up with?
So we have been partnering with a commercial company, Oxford Nanopore, to develop something called LAMPOR. And that's a technology that can amplify the genetic code of the virus very quickly in under 30 minutes. The difference between whole genome sequencing-based tests in COVID is that they can give you information about the virus itself, how it spread, where it's come from, how it's going to evolve, allows you to track the progress of the virus through a population, and also allows you to understand where it's come from and where it's going. Mass testing without sequencing is essentially just a yes or no answer. Yes, the virus is there. No, it's not.
So is the focus of the tests that you're doing on asymptomatic people?
That's correct. So we're looking, as part of this project we've done recently, at following a cohort of patients, or members of staff in this case, 1,000 of them, and seeing whether, if by testing them every day, we can understand whether we can detect the virus before they get any symptoms. And the simple answer is yes, we can. And also we can see and identify people who've got the virus, stop them from spreading it by breaking the chain of transmission, and then also working out where it's come from in the first place.
That could be applied to people in all sorts of different sectors. That could be incredibly useful, presumably.
That's right. So at the beginning, we have done it on members of staff in hospitals, but we also know there are other high-risk areas, for instance, universities, care homes, and even large factories, say food factories or engineering plants. These are also high-risk areas. So by combining sequencing with COVID testing, not only can we see whether somebody's got the virus in the first place, we can also understand how it was introduced and track it back to its source and try and eliminate these chains of transmission.
God, that's fantastic. So schools, I mean, sitting here as a parent, I'm thinking brilliant. If you could roll this out across schools, that could save a lot of classes being sent home.
Yes, that's correct. And I'm a parent too. I have a young child. And I think one of the worry for all school parents is that you introduce COVID into a school environment, it spreads very quickly and you can't get a hold of it. You can't work out or understand where it came from. And by doing this type of technology, it will give us a bit of grasp on it.
And how are these tests going to be rolled out?
So we're really fortunate. The testing, we've done a complete workflow. So we've shown how you can go from a sample, analyze it and give an output all as quickly as possible. So we've done the hard work first, and we've understood through the research where the pain points are. So in other words, why people might not take part in the testing, if the test doesn't work, why it doesn't work, how we can improve sample collection, how we can feed back the results better. And so this should allow us to drop it back in as part of a larger infrastructure into places like schools, hospitals, universities and other community settings.
How exciting to achieve so much in such a short period of time.
It's only really through extensive teamwork. This is definitely not a solo endeavor. There are labs and casts of literally hundreds of people working on this, and each of them plays a part. And it's only really by using the knowledge that we've gained from our genomic analysis of cancer that we've been able to rapidly help improve these and develop these tests for COVID.